Lungang. One of the craziest statics of rigid bodies question you could be asked in your exam. Let's go through it, mate. It says, the figure shows a uniform rod AB resting on a rough peg at C. The rod has weight W and length 6 meters, given AC is 4 meters, and the coefficient of friction between the rod and the peg is 0.5, and that the rod rests on rough ground with coefficient of friction mu. Show that mu has to equal this depending on theta, innit? The system is in limiting equilibrium. Okay, so it's all about your diagram, all right? Let's just read again and start adding our forces. Shush, little. It's always little, man. So it's a uniform rod, meaning the center of mass is acting through the center, and it did say that the mass of the rod is W. Okay, so we're gonna put straight down the middle. We're gonna draw long lines. That's W. This is 3. Okay. Now I don't like to put too many lengths on the diagram, so I don't like lengths overlapping. So they did say that AC is 4, meaning this is 1. Okay. And it's resting on C. Now C is a circle, so there'll be a reaction force here. We'll call it N, a normal reaction force. It will be perpendicular. We also have the rod resting at A, so there'll be a reaction force here. We'll call that R. Okay. Now the key part of this question is that it's saying that both the peg and the ground are rough. Okay. So they did say that the coefficient of friction between the peg and the rod is 0.5. Now you just got to think, what does the rod want to do? The rod wants to do this. It wants to slide down this way. If it wants to slide down this way, the friction at the peg is going to oppose that motion and point up this way. Okay? And because it's in limiting equilibrium, it's going to be at its maximum. Okay? It's at limiting equilibrium at both here and here. Okay? So we're going to use mu r. Mu is 0.5. R is N. It's the contact force with C. So we have mu, which is 0.5 N. Now also down here there's friction, right? Remember, it wants to move this way. So there's going to be a friction force pointing this way. And that is mu R, because the coefficient of friction there is mu R. Okay? Now usually what we do with these questions, we say up, down, left, right. Up, down, left. This, it's not looking good, mate. So before we do up, down, left, right, let's just work out what one of the values are. And we could do that by taking moments about A. Now there's a reason why I'm choosing moments about A. So this is a unique question where they are putting friction at the peg. Now at A, R disappears, mu R disappears, because we know that a moment is force times perpendicular distance. But because these forces run through A, their distance is 0, so there is no moment force, there's no turning force. But also, this, remember guys, forces don't have a length, okay? So this, you can extend the line, when in doubt, extend it out, goes through A as well, so this disappears, okay? The only two forces we're interested in is N and W, okay? Now you put your pen on A, you follow the line, then you point towards the direction of W. So this is a clockwise, and N is an anti-clockwise, okay? Now this is an easy one because N, you can see its perpendicular distance from A, it's 4. So we're going to have 4N equals W. Now W is a vertical length, a vertical force, so its perpendicular length is going to be horizontal. It's this one. That'll be 3 cos theta. So we have W, force, times perpendicular distance. Okay? I'll leave it like that. We'll decide what we want to do with that later on. Now we can do up, down, left, right. All right? Now to do that, we need to resolve N. Okay? Now N is pulling this way, so it's going left and up. Now this is a common force that we need to resolve. Now I want you guys to remember that theta is the same up here. These two are always the same. Just like Joe, when we resolve this, we always remember that these two are the same. Same thing here. Now why is that? If that is theta using alternate angles, this is theta, this is 90, so this is 90 minus theta, that's 90, so that's theta. Okay, so now that I've shown you very quickly, you can believe me now. So N is in the hypotenuse, this is the adjacent side. So this is N cos theta, pointing up, and this is n sine theta. You can see how everything is done on the diagram. But also, we need to resolve the frictional force. Okay, this is theta, this is both horizontal, this is our corresponding angles. This will be the same. So this adjacent side will be 0.5 n cos, and this will be the ops. That'll be sine. So that's dealt with, and that's dealt with. Now we could do up, down, left, right. Let's do up and down, because we're trying to rearrange for mu, we might as well do that one after. So looking at the up and the down, you can see everything is done on the diagram. R, and, let's tick it off, R, and n cos theta, and 0.5 n sine. Anything else pointing up? It don't look like it. Must equal W. Okay, what are we going to do with that? I guess we can replace n with W. Is it really necessary right now? I'm not too sure. I don't think so. I'm going to leave it like that for now, and we'll see what happens later. Let's just do the left and the right. Yeah, don't do too much, all right? Just see what happens. If we do left and right, I see that pointing to the left is n sine theta. Yeah? And that has to equal this and this. So that has to equal 0.5 n cos theta and mu r. Okay? Now we take a look at our diagram and make sure everything's ticked off. I didn't tick that one off, but that was here, right? Everything's ticked, so I'm confident I've used every force. So now we need to rearrange for mu, right? I'm going to eliminate r by rearranging this. Okay, so r is w minus all of this. I'm going to write like this, 0.5 n sine. Let's plug it in. So we have n sine, here we just need to be careful. It's a half n cos plus mu lots of all of this. That'll be mu w minus, what am I multiplying by? Mu n cos minus a half mu n sine. Okay, I guess we can double everything. But should we start replacing? I guess what we can do is, could we replace W here? Yeah, if we replace W, then we can cancel out the n's, right? So here, W is 4n over 3 cos theta. Okay? So W is 4n over 3 cos. I'm just going to replace it here so I don't need to write the whole thing again. So, wait. I rubbed out the wrong thing. That was an n, right? I think so. I guess we'll see. That's W. I'll do it with a different color so you guys can see. This is 4n over 3 cos theta. Okay. Right, so I can cross off n everywhere. Instead of me just messing everything up, let me just rewrite the whole thing without n. But also, I'm going to multiply everything by 2. I could do 3 cos theta, but I'm worried I'm going to make a silly mistake. So I'm going to get rid of n and times by 2. So 2 sine is, get rid of the n times by 2. We just get cos plus, get rid of the n times by 2. We would get 8 mu over 3 cos. Minus, get rid of the n times by 2. 2 mu cos. Minus, get rid of the n times by 2. Mu sine. Okay. I guess now we can... What is it? We do want to turn into tan, right? Do I really want to times through by cos? Because cos in the denominator is a good thing, right? Yeah, I'd rather be sine over cos. I can change that to tan by dividing by cos, divide by cos. The problem with that is that won't disappear, but divide by cos, divide by cos. However, I'm going to see something. I'm going to divide through by cos. I'm going to do something cheeky here. So if I divide that by cos, I'll get 2 tan is 1 plus 8 mu over 3 cos squared. And maybe you guys are starting to see what might happen here. What am I thinking about? Minus 2 mu minus mu tan. Cos squared in the denominator is the same as sec. Okay? Sec squared. Well, it's sec, but sec squared when you bring that up. So this is sec squared, which using our trig identities is 1 plus tan squared. Okay, good. So that's what I'm going to change that to. That is 1 plus tan squared. Remember, we're trying to keep everything in terms of tan. I'm going to times through by 3 and change that to 1 plus tan squared. So I'm just going to write t now. 6t is 3 plus, so I've times by 3, 8 mu, 1 plus tan squared is that, minus, times that by 3, 6 mu, minus 3 mu t. So I'm going to minus the 3. Look, 6t minus 3, that's looking good. I'm also going to factorize out a mu from here. So we get 8t, what? 6t. So I have 6t minus 3 is mu, expand the 8. 8 plus 8t squared minus 6 minus 3 mu. 3t, sorry. Which is 6t minus 3 is mu 8t squared minus 3t plus 2. Oh, let's go. Therefore, mu is 6 tan theta minus 3 all over 8 tan squared theta minus 3 tan theta plus 2. And that is our answer, and that has been proved. That's an intense question, guys. Yeah, if you learned something today, I'd appreciate if you hit the like button, subscribe for more maths content. If you're interested in my A-level maths courses, then there's more details in the description. And feel free to join the Learn Gang Reddit page to submit your own questions and get feedback from the community. I'll see you in the next one. Nice.